Thank you. Thank you for this wonderful introduction, and thank you all for coming today to discuss this work. It's on the second of the topics that were just mentioned. It's the relationship between how we do make moral decisions, so that's a psychological question, and how we ought to make moral decisions, the normative question. So, working in distributive ethics, some of you I know work in this area, others may work in other areas like philosophy of language or in metaphysics. Philosophers often draw on intuitive judgments. We have a judgment about a case, and these judgments play a role in developing and justifying our theories. But we are all aware, and especially recent developments in psychology have made us even more aware of the fact that our judgments about particular cases are not always reliable. Psychologists have been mapping out in great detail what they call the heuristics and biases, the quick and dirty rules for making judgments and inferences that we use in a whole variety of cases. And so I've become interested, as one of the people who relies on intuitive judgments and who thinks that we cannot do without them in doing moral theory, I've become interested in seeing how far this psychological critique of some of our case judgments extends to our judgments in ethics. So this is a first step, a first attempt for me in this area. I'm not that experienced in doing experiments, but I've tried to work together with some other people who are. So Arnold Stephenson is one of my co-authors. He helps me with the statistics. Ken Binmore, a well-known economist, but also experimentalist, consulted on the design of the experiments, and Brian Wallace runs the lab in which the experiments were conducted at University College London. And so the question I want to look at today is, when can, and also when can we not, trust our intuitions or case judgments? If you want to know what intuitions are, they're basically the case judgments about a case that come to mind quickly and without consulting explicitly a theory. When can and when can we not trust our intuitions in distributive ethics? Distributive ethics is the field of ethics in which, say, you have a limited amount of resources, unlimited need, or at least needs which far extend beyond what you can meet with your resources, and you have to decide to prioritize one over the other. So, I know some of you may have seen the handouts before, but let's try to imagine that you are new to this question. I'm going to give you now one of the questions that I posed to my subjects in the experiment, and let me explain what the question means. So the subjects had first several pages of explanation of the following kind, which I'm going to run through in a very brief moment with you. You're going to be making choices which group of individuals to help cure of a particular health condition. The number of individuals in the group that you could cure is given in the box, either 48 or 27. You cannot cure both groups. Now, what is this index that you see here between 0 and 1? This is what's known as the health-related quality of life index. This is an index that is used by many governments and international bodies, including the World Health Organization, to try to have an estimate of how good or bad it is to live in a particular condition. So 0 is a condition that is equivalent to dying, right? So quite a bad condition. It goes below 0 actually, but I want to spare you the gory details. 1 is a condition of perfect health. Okay. So a condition of 0.95 is one with rather moderate impairments. Right? So an example of what in some surveys, I'll explain a little bit more about this in a moment, is a condition like that, is moderate to mild chronic pain that does not prevent any activities. Okay. 0.91 is somewhat worse. That might be moderate pain that does not prevent any activities, chronic pain. Or it might be a moderate mobility impairment. Now, what do these indices mean from 0 to 1? They are so constructed that the scale is meant to be cardinal. What this means is that a given increment of a particular size, so moving, say, from 0.95 to 1 is an increment of 5 hundredths, is just as much of an improvement no matter where you start. So moving from 0.5 to 0.55 is just as much of an improvement in your health-related quality of life on this scale as moving from 0.95 to 1. So I've given you in a brief moment what I gave my subjects in somewhat longer slides, the idea of a cardinal scale, a health-related quality of life scale. So we're to imagine these individuals are all young individuals and they will live for a normal period of life in this health state until death, except if you intervene to improve their condition. And you have to choose whether to move the 48 individuals to 1 or 27 individuals to 1 from a somewhat lower point. With this explanation, take a moment and think for yourself, which side would you choose? And maybe take a note. It'll be interesting later to compare it to the answers of my subject. Okay, here's another one. Again, you have a choice. You can either move 10 individuals up from 0.31 to full health, or 20 individuals from 0.7 to 1 to full health. Again, maybe take a moment to think about it and then write down your answer. Yeah?
But how bad is it to have the 0, 3, 1?
Here, 10 individuals.
No, but how bad is it to...
How bad is it? Well, significantly better than dying, but quite a large distance away from 1. This isn't, it's an invented skill, but a skill that is used. I'm not making up the skill. If you want to know how they generate it, it's basically, roughly, 10 years living in a 0.31 condition is equivalent for people themselves living 3 years in full health. That's where they get the 0.31 from. That's one of the ways they arrive at it. Yeah.
From which part of the globe do you get your samples?
I'll get to that in a moment. Yes. Yeah. The scale has nothing to do with my samples. I used the scale that is used I used the Health Utilities Index developed by McMaster's University. But let's assume for the moment, I know it's rather abstract, that this is a cardinal scale of well-being, where you have a sense that the gap between 0.31 and death is much less than between 0.31 and full health. Okay? And 20 on the other side. Good. So I've just tried to elicit from you case judgments, also sometimes known as intuitions. That's to say, you probably didn't have time or the inclination to apply a full theory to this case. I simply gave you some basic information and you had to make a quick judgment one way or the other. Now, when do we rely on such intuitions? Well, one example is the question, how much additional weight, if any, ought we to give to the worst off? Many of you will be familiar with the utilitarianism, right, which will say no extra weight at all. If these are utilities, if these are well-being measures, we should simply do in each case what maximizes the sum total of utility in the population. But many people like myself, I've spent many years with many others, of course, have done so, arguing against the utilitarian view, that we ought to give some extra weight to people who are worse off than others, in my view on egalitarian grounds. But how much extra weight? If we can move one individual up from a low level by just a little bit, or a lot of other individuals from a higher level up by a great deal, at what point does my concern for equality give way to the fact that I can do a lot of good for people who are already better off? It's implausible to think that equality is the only thing that matters, or that helping the worst off is the only thing that matters. So we have to trade them off against each other. There is, in my view, no simple formula for this. We have to appeal to our case judgments at some point to arrive at a sense of balancing of these two cases. So, in a theory like mine and like many others, I think it's unavoidable that at some point we also draw on intuitive judgments of the kind I just presented you. So that's my claim. I just articulated intuitive judgments must play a part in finding the answer to this question. But, as I said right in the introduction, and any of you who, for example, have read the popular book Thinking Fast and Slow by Daniel Kahneman, right, will know that our intuitions are often unreliable. So, it's as if we have an extremely unreliable instrument. We're doing science, right? Imagine we were doing science. We have a very unreliable instrument, but we have no choice but to use it. That's how I see our intuitive judgments, our case judgments in distributive ethics. But we have a way of perhaps attempting to decide which some of these judgments are more unreliable than others, or more reliable. This is why I think psychology can help. Because if you read Kahneman's work, among many others, what they try to do is they try to uncover the principles that govern our intuitive judgment, which are not open to introspection. And sometimes when we understand those principles, they vindicate our intuitive judgments. Sometimes when we understand those principles, they undermine these intuitive judgments. So here's an element where I think psychology can help. Of course, not psychology alone. Psychology plus normative judgment about the reliability of the processes that give rise to our intuitive judgment. But nonetheless, it's an area where philosophers, I think, need to appeal to some psychological knowledge. So, the argument that I plan to develop to you today is that when we do such a psychological investigation about the type of judgments I just exposed you to, alternatives like the first, 48 versus 27 one, the very first I gave you, are inappropriate because they induce, in some part of the population at least, the use of an unreliable heuristic. Heuristic is a quick and dirty method of making decisions, known as similarity-based decision-making, which I will explain. That's the main claim I tried to investigate in the experiment and that I will try to argue today. Whereas alternatives of the second kind, with 10 at point 3 versus 20 at point 7, are much less unreliable, but are in fact better for eliciting our intuitions. So what is similarity-based decision-making? We'll now go to the non-moral domain. This is the paper, as far as I know, that first developed the hypothesis that people use similarity-based decision-making. It's by Amos Tversky in a Psychological Review, if I remember correctly, 1969. And he hypothesized that people find it difficult to compare alternatives with many dimensions when they are unfamiliar about how to trade off these dimensions against each other. So, what I'm describing here is one of his experiments with Harvard students at the time. And he told them the following thing. He said, "We have developed a new way of measuring the quality of applicants to Harvard along 3 dimensions. I, intelligence, E, emotional stability, and S, sociability, on a 0 to 100 scale." Okay? And we don't know how to trade these off against each other. So who better to ask than these brilliant students who we already let in at Harvard, right? You. Okay? And we would like to have your opinions by making pairwise comparisons. And you would give them cards with two candidates, so candidate A or B. These candidates would be described along these dimensions as follows. He didn't highlight the one, I'll tell you about that in a moment. And asking students to make pairwise choices, who would they rather let into Harvard? And he hypothesized that a substantial share of subjects might reason as follows. I don't really know how to trade off intelligence against emotional stability and sociability, and what exactly do these indices mean anyway. But I can tell that candidates A versus candidate B does not have a big difference in intelligence. But the gap in emotional stability is rather significant, right? And that guy is a lot more fun. A is a lot more fun to have around than B, right? So, minor difference along intelligence, substantial differences along emotional stability and sociability. Let's go with those. Okay. Now, this is an example of similarity-based decision making. Why? You say, I don't know how to trade off the dimensions exactly against each other. Let me look for similarity and then eliminate the dimension along which there's similarity if there is dissimilarity along other dimensions. That's a rough heuristic. Makes perfect sense, I think. But we can see what happens if you iterate this. So suppose, as he did, present ones with, they were always presented just with two at a time. A compared to B, you prefer A, right, on these grounds. B compared to C, the same logic tells you to prefer B. C to D, the same logic tells you to prefer C. D to E, again, D. Right? Always a somewhat less intelligent person, but who's more sociable and more emotionally stable. But now, compare A to E. Okay. 69 on intelligence, 81. This is Harvard, for God's sake, right? So he's a bit nerdy, right, and not that much fun to be around, but we should let the most intelligent people in, right? So he hypothesized that some individuals would, at the end, be over A. Right? Why? Because now there is no similarity along any dimension, and you must appeal to a different rule in order to rank A and E. Now, notice this was not universal, but still, he found 42% of subjects revealing this type of intransitivity, which he said suggested that they were using a method of this kind. Now, I have a picture of a bird. If a heuristic is a way of dealing with bounded rationality, trying to make a decision that you have to make under limited computational ability, limited judgment ability, we should expect to find it not just in human animals, but also in other animals who have difficult trade-offs to make. And indeed, so we can find it among birds. Intransitive preferences in gray jays, these were multidimensional alternatives. I think, if I remember correctly, they were plastic tubes with raisins at the end. Now, crawling into a tube is difficult and painful for this bird, but the raisins are very nice. Right? The length of the tube was one dimension, and the number of raisins another dimension. And I can't remember in which way it went, but in any case, the gray jays displayed similarity-based decision-making about whether to enter a tube or not, etc., depending on the number of raisins and the length of the tube. And they could display similar intransitivity in which tube to go through. And you all know the song, birds do it, bees do it, let's do it. So I didn't try to make this up, right? I mean, apparently there are also honeybees with a similar thing, a sugar concentration at the end of a long tube, etc. So rather than sing a jazz song classic to you now, you get the idea. A heuristic of this kind has its uses, apparently, right? We might use it, but also animals who are also boundedly rational might use it. My question was, might we use it in difficult moral trade-offs? That is the attempted novelty in the experiment. Experimental setup, an explanation somewhat longer than the brief one I gave you, of the Health Utilities Index, followed by a practice session of 4 choices, which didn't count. 16 real choice pairs, repeated 3 times, but in randomized order and randomizing left and right the screen. So 16 times, 16 choices, but which was left and which was right was determined randomly. So, individuals made 48 choices that counted, plus a basic understanding test, 3 choices where one side dominated the other, both saving more people and from a worse condition. Right? Why did I put this in? Well, because the subjects were being paid only for being in the experiment. They couldn't win any money or something like that. So I was concerned that some subjects might come in like this. Click, 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 click. Can I please have the money? Right? So this was a test of whether they were paying attention, also whether they understood what was going on. To my great relief, and to the surprise of my economist colleague who thought if you don't incentivize people, they switch off, 95% of subjects passed this test, chose the dominant alternative or the dominated alternative. So we had 82 subjects, which meant that I had 79. I took out the 3 subjects who failed the test. So before we look at how my subjects made the decisions, let's think about philosophical theory, about how should people make the decisions, and then how people do make these type of trade-offs. So here we have our philosophical gallery of honor. Right on what for you is the extreme left, we have Rawls. Now Rawls, I know, didn't write about healthcare. Right? He might not have applied Maxim in there, but he's associated with this Maximin idea, which is you should always give complete priority, lexical priority, to improving the situation of the worst off, no matter how little you can improve them, no matter how few they are in number. So that's the extreme left. Now, in the middle we have John Stuart Mill, right, the utilitarian view, which I articulated before, and this may be a little bit unfair to Friedrich, but here we go. Maximax, do everything you can to lexically improve the people at the top first, before you improve anyone else. I'm not sure that it's entirely fair to him, but it fills out the scheme nicely. Now, I'm going to argue, sorry Friedrich, that the reasonable range, the range where most philosophers argue, right, is somewhere between Maximin and utilitarianism. The standard argument is not, should we sacrifice total utility for the sake of the better off? That would put us on the right. But rather, ought we to sometimes be prepared to sacrifice total utility, the aggregate, in order to do more for the people at the bottom? That would put you to the left. And you can see there's a continuum depending on how much extra weight you give to the less well off. Now, where are people? The typical person is in the reasonable range, actually somewhat to the left of utilitarianism. So there have been extensive surveys mentioned here by Eric Nord, a Norwegian economist, health economist, some American psychologists and economists. Recently, Nord has just published an overview. It's not just those champagne socialists in Norway. It's very easy to be left-leaning when you have $700 billion in the bank from your oil wealth. But it wasn't. His initial surveys were among Norwegians, but his recent overview work suggests that 19 different countries find generally a rather strong bias towards the left in healthcare allocation decisions. So the typical person is prepared to sacrifice some total well-being for the sake of the worst off. Now, how do you show that people are using a heuristic? One way to show this is to show that they are making choices that are rationalizable, explainable, only by that heuristic and not by ordinary, reasonable methods of decision-making. That's why the heuristics and biases appears to focus so much on experiments in which people are stupid, supposedly, right? The conclusion to draw from the literature is not actually that people are stupid, but it's part of the methodology of investigating. Suppose I argue that you're using similarity-based decision-making, but what you're doing is also perfectly explainable by moderate egalitarianism. Okay? Then I have two competing hypotheses, both of which fit the data. The way to bolster my case that you are using similarity-based decision-making is to show that you are giving priority to the better off at a cost in total well-being in a manner that is inconsistent with reasonable set of preferences that people like you, and maybe even you, in other choices have. So the conclusion is that that has something to do with why this literature is often accused of making people look stupid. In part, it's just a methodological question. I can only establish what I'm trying to establish by showing that people move out of the ordinary range. So that was my attempt. Tversky's original case tried to show that people are violating a formal principle of decision-making, transitivity. Right? They prefer A to B, B to C, etc., but then E to A. I will look at transitivity, but what I attempted to do here was look at a more substantive principle of rationality, if you want to call it that. Namely, to see if I could induce people to make choices contrary to what I think their considered preferences would be, or preferences that fall in a reasonable range. So, how would one try to do that? Well, this is in a table describing the first pair of alternatives that I showed you. A was to save 48 people whose non-treatment health was 0.95. The sum of the utility gain was 2.4. B was to treat 27 people whose starting point was 0.91. The sum of utility would be 2.43. Now, this means that B is the alternative which generates the greatest utility, but also the one you would choose if you were Rawls. That improves the situation of the worst off maximally. Okay. So, from left to right, anyone in the reasonable range would say, let's do B. However, I hypothesized that, look, these are unfamiliar concepts to individuals. Even though I tried to explain it to them, it's difficult to make trade-offs between severity of illness and number of people you can save. It's not something we're used to doing. So some share of subjects might use similarity-based decision-making to make this choice. They might say, look, 0.95, 0.91, no big difference. They're both reasonably well-off people. But look at the difference in number. I can save almost twice as many people from 0.95 as I could save at 0.91. So similarity-based decision-making would say the number is very different, dissimilar. 48 is very dissimilar from 27. 0.95, 0.91 are quite similar. So I make the decision on the basis only of the number, not of the no treatment condition. Is there anyone here who chose A? Thank you. At least I can count on one.
I can calculate it fast.
So that's fine because firstly, it's not clear what the calculation would necessarily yield, right? But
I think I used SPDL actually.
Yeah. Okay. So you did. So at least we have. Thank you for being so kind. At least we have one in the audience. We'll see whether my subjects were more numerous or not. And then I tried to do it with some more alternatives. So you see, B and C have the same relationship. 0.91, 0.87, not that big of a difference. 27.19 looks quite different. As you go down the scale, it becomes harder to find such cases, right? So 19 to 15 actually look already quite similar, and 27 also relatively similar. So the effect should be stronger between A and B and C than between C and D, etc. So here's one hypothesis. If people use similarity-based decision-making for adjacent alternatives, and the number of individuals you can save is judged to be dissimilar, whereas the harm you can save them from is judged to be similar, then you would get A is preferred to B, is preferred to C, is preferred to D in pairwise comparisons. But all preferences in the normal range are the opposite. So this is just original choice, only B is the one in the reasonable range. Now, of course, we need a point of comparison. So we need alternatives which are dissimilar along both dimensions. So that was, for example, the one that I gave you, the second choice I gave you. Here we have 10 people whom we can say from point 3.1, or 20 people from point 7. Again, saving the worst off is also the utilitarian answer. And here the prediction would be, look, there is no dissimilarity along either, there's no similarity along any dimension. So you're forced to make the trade-off or to use some other rule, now that there is no similarity. Then people will revert to the normal range. People will be choosing R over S. Now, I must admit that I made a mistake in one respect in designing the alternative here, which only occurred to me recently after I'd done the experiment. 0.69 and 0.60 are about 15% apart. The ones I showed you before are much closer together. I should have made them equally close together. That was, unfortunately, I don't know why I did that. Fortunately, I have many such alternatives. Some were much closer together than others. Yeah.
I see another problem actually. If you expect people to make calculations, it's better not to use scales with all points,
Yeah.
which makes things much more difficult. It would be evident if the scale would be from 0 to 100 or 0 to 10.
Yeah. So I didn't expect people to do calculations. I wanted them to simply look at roughly how to make the intuitive judgment without doing the calculations. I will tell you later about one subject who did more or less make calculations, but the attempt was not to induce people to make calculations, right? Rather to have two different measures which aren't straightforwardly trade-offable against each other. These were people who had not done philosophy before, never heard of utilitarianism, probably, right? Simply to see if I could find out their method of making decisions. But there's nonetheless, I ought to have made S closer to R. That was a mistake. But in any case, the idea is that the majority would here choose to help the worst off in the normal range because they're forced to, they cannot apply a simple heuristic like similarity-based decision making here. They have to do something else. Balance the number saved against the severity of harm you save them from. So here's the first prediction. Similarity-based decision making makes priority to the better off. That means helping the better off at a loss in total utility, more frequent in similarity choices than in non-similarity choices. Notice this is a relative judgment. The judgment is not that everyone will choose according to similarity-based decision-making in the one and no one in the other. It will be more frequent. And the second prediction is that in non-similarity choices, we will find what people like Nord found in their surveys, namely priority. People choose in the normal range, in the reasonable range. Then I had a further set of questions. Would people be willing to sacrifice total utility for the sake of the less well off in my sample? So, not just would they move back to the reasonable range, but within the reasonable range, would they be more to the left? So here, F and G, right, here's a person whose quality of life is extremely low, 10 people, barely better than dying, so a life barely worth living. The gain is somewhat less than if you move 50 people from point 8 up to 1. Okay. So here you would have a conflict between the utilitarian answer, which would be to move the 50 up to 1, and a modest, even if you're just a very tiny bit egalitarian, you would move this up. Here I was better. I was closer to the edge as I should have been in all the way. Very small difference in total utility.